Binomial distribution also has a mean and standard deviation for binomial distribution. Let's say this, just for the sake of discussion. Suppose you flipped a coin 10 times. About how many heads would you expect to get? Well, since it's a 50-50 chance of getting a head or a tail, you would expect to get half of them would be heads. About 5 heads would be the expectation. Now, you're not going to get 5 heads every time, but if you had to pick one number, that would be the expectation. So that's also the mean. So this is a Greek letter mu, stands for mean, is equal to n, the number of trials, p, which is the probability of success. So if I flip a coin 10 times, and the probability of success is 0.5, 10 times 0.5 would give you, this is the number of trials, this is the probability of success. So in the flipping a coin 10 times, it would be 10 trials times 0.5. That would be 5 would be the mean or the expectation of how many heads you would get. There's also a formula for standard deviation in a binomial distribution. The standard deviation is equal to the square root of n times p times q. Now q is the probability of failure, which by definition is 1 minus p. So just to do an example of this, let's go back to wilt. Let's see, let me go back to wilt probability. Wilt makes a free throw is equal to 0.509. So let's find the mean and standard deviation if he makes 32 free throw attempts. So that gave p was 0.509. Let's make n equal 32. Now I'm picking that 32 for a reason. Find mu and standard deviation sigma. This is standard deviation for Wilt's 32 attempts. Okay, so the first thing is that the mu is np, so it's 32 times 0.509. 32 times 0.509, which comes out about 16.3 if I round that off to 1 decimal place. 16.3 would be how many free throws you expect Wilt to make out of 32. And then the standard deviation sigma, the standard deviation, the square root of npq. Remember, q is 1 minus p, so it would be 1 minus 0.509. So that q I'm going to enter there is 1 minus 0.509, which is 0.491. So the standard deviation for Wilt's 32 free throws, n is 32, p is 0.509, q is 0.491. It's a square root, so there's square root 32 times 0.509 times 0.491, and that comes out about 2.8 if I round that off to 1 decimal place. This is about 2.8. Now, one more thing about this, there is what's called the range rule of thumb. So if you have a value of the random variable x that is significantly high, that would be more than 2 standard deviations above the mean, more than mu plus 2 sigma, and a value of the random variable x that's significantly low. This would be less than mu minus 2 sigma, more than 2 standard deviations below the mean. Now, Wilt is famous for having scored 100 points in a game, and in that game, Wilt made 28 of 32 free throws. Wilt made 28 of 32 free throws in his famous 100-point game. And the question is, let's find the cutoffs for Wilt's significantly high and low values. And what about the third to 28? What about the fact that he made 28? Okay, so the significantly high is mu plus 2 sigma. We calculated the mu and the sigma. What was the mu? Oh no, I forgot. Let's see. I can calculate. Oh, there it is, 32 to 16.3, I think it was. It's 16.3, and the sigma was 2.8 plus 2 times 2.8. 16.3 plus 2 times 2.8. So that's 21.9. The significantly low, this would be mu minus 2 sigma. So that would be 16.3 minus 2 times 2.8. 16.3 minus 2, 16.3 minus 2 times 2.8 is 10.7. So anything above 21.9 would be significantly high. So that 28 that he got that one game, that was a significantly high number of free throws for Wilt to make out of 32. So because since 28 is more than mu plus 2 sigma, which was 21.9, 28 is significantly high.